I just sent you an email about the project group members. So if you need to, if you need to find other group members, or if you don't have any other group mates, you can send me an email. I'll try to match the groups and the persons who are looking for groups. So we will try to resolve those groups as soon as possible. And I strongly recommend you to finalize it either today or tomorrow, so that you know what you are going to do next week and on the coming assignments. So going back to the example that we were dealing with, if you remember, this was a frame that we created, frame, new frame, authority, and then we mentioned a couple of things. We added a panel, and then within this panel we added two labels. Then we add this panel onto our frame at the end and print the have this printed on the screen at the end as a frame. So if you execute this, compile it, and then execute it, you can see that this is what has been shown on the screen. And as you see, this is the title of this frame, authority frame, and then you have the first line, the first label added, and then the second label added. Actually, this is the size of your panel, and then based on the size of the panel, so if this is the panel size, so we added the first label and then the second label. Based on this panel, now you have your panel, the frame will have the size based on that panel. Okay, if you have more than one panel and they're, let's say, added both on your frame, what is going to happen is that frame is going to set its size based on those two frames, those two panels. So let's say I have these two panels and then I add them on my frame. Then when I call frame.pack, my frame is going to be set the sizes. My frame is going to set the sizes such that it has both of these panels fitting into the same area, same frame. Okay. So this pack method actually is called to exactly pack these panels onto the correct size, and then once you say set visible true, it is going to show it. Also, you could have said frame.show in order to show this frame on the screen as well. So it doesn't matter, they do the same thing, but you could set visible true is chosen here. Okay, so again I have the new panel that is created, and then the color is set to yellow, and primary set preferred size, so the dimensions are set to be 250 and 75, and I added those two labels onto this panel. Once I set the size, I created the labels first and then add them onto the panel. Then I added this primary on my frame, this panel on my frame, and then pack it to get the correct size and show it on the screen afterwards. Okay? So if you happen to change this to, let's say, if you play around with the size, such as I made it, instead of 250, I made it 550, and I compile it and execute it, as you can see, the size is, got enlarged, and you see a bigger frame on the screen. Again, my panel is bigger now. Frame is set to be a bigger frame based on that panel. So let's say if I wanted to add more panels, you can do that. We will see how we are doing shortly. So going back to the example and slides, it is not an interactive program, but it can, it shows how this is executed and how it is operated. You can reposition the frame, meaning that you can, move it around and just wherever you like. So it's possible to do that on the frames. So let's continue. Nested panels. So you can have within one panel, you can put another panel and have a nested implementation. Containers that contain other components form a containment hierarchy. So let's say I'd like to have a panel, and then within that panel I will have two panels, and within this lower panel I will have two or four or three other panels, so you can form a hierarchy. Again, this helps in organizing things on the screen. So you may, adjust the sizes and things like those in order to put them in the correct locations. So if you start playing around with panels and frames, you will see that you will need to form these hierarchies in order to locate or put things in the correct locations. So let's see this nested panels example. Again, this is a standalone application. I'm just going to execute it from the JCreator. So when you look into this example, again, we have the packages that we import, and then I have my class name nested panels, and I have the main that is going to start execution. Now, next thing I do is I create a frame. So this is the main frame that I'm going to use. New JFrame, nested panels is going to be the title on the top left corner of this window. And then I set this, whenever I close it from the corner, what is going to happen? I'm just going to close it. Exit on close is the default thing that you most of the time choose. There are other options, but again, it's up to you to choose what you would like to do whenever the user presses that close thing. And then I create a first subpanel 1, JPanel subpanel 1, new JPanel. So we created this new panel, and then I set the size to be 150 by 100. And the background color is set to be green, and then I have a label that is created that is a text string have as 1, and then subpanel 1 add label 1. So now I created this dimension. The color is set to be green, and I added one label that prints 1 on the screen. And then I have another subpanel that I'm creating. So this is the subpanel 2. So I have the same exact thing, same size. The color is red, and then I have a label that prints 2 on the screen, and I add this label onto my panel. So I have the second panel, exactly same thing, just green and 1, red and 2. And now I set up the primary panel. Now I have new JPanel. This has a color of blue, and then I add the first subpanel to my panel, and then add the second subpanel, which is defined to be subpanel 2. I add that too. Now I have the panels both in the same panel. Then I add this primary, the main panel that I'm using for, onto my frame. Then I pack to get the correct size. And once I get the correct size, I have it shown on the screen. So if we compile this, is it finished? Okay, now it's finished, and if I execute this, as you can see, I have the nested panels title on the left topmost corner, and then I have the 2 subpanels, 1 with green, 2 with red, and then I have the blue panel that is right below those 2, which is the primary panel that these 2 go into. Okay, so based on this, my frame is set to have the size, whatever that pack method at the end executes. Okay, any question? So you can align them in different orders and in different ways, but we are not going to do it right now.
Hocam peki label'ların büyüklüğüne nasıl karar veriyor? Yani hani karakterin uzunluğuna falan. Mesela yazıyı yazıyor ya, Van yazıyor. Nasıl onu o şekilde yazıyor? Hani daha büyük ya da küçük olmasını ayarlayabiliyor muyuz?
There are fonts that are set as default. So if you want to modify the default font and set it to print in another format, you can do that. You can change the font, but they have a special or default font that it comes with. So you use that font at the beginning. If you want to modify, you can do that. So this is nested panels, and images. You can also, use images in graphics, components. So if you would like to import these images in your screen, let's say you would like to have a certain image on the back of a, panel or a frame, then you can do that. You can use JLabel object to add those into your frame or panel. So you can use this again along with the text, image, or both of them at the same time. So image icon class is used to represent that is stored in an image. So we will see that in the example. The position of the text relative to the image can be set explicitly. So you can reposition the image and the text according to what your requirements are. And we will see how we are doing that. The alignment of text and image within the label can be set as well. So let's go into the label demo. This will make things a lot more clear. So if I go... So this is the label demo application. Now I have again the imports, and label demo is going to be the class name. I have the main method. Now I have jFrame frame. I create my frame to have the label demo as its title, and then I set this default close operation as before, just to exit the whole application. So that's what it is going to do whenever you hit that cross. And image icon. So I'm creating a new image icon that is going to get the file that is exactly in the same location with my application devil.gif, and it is going to have this name. So this is going to be my images identifier that I can use. I add 3 labels: label 1, label 2, label 3. This is just note that they're not created yet. And next thing I do is I create them. Label 1, new JLabel. So I'm going to create a JLabel with devil left as the text, and then icon swing constants. Center, you can't see that part. Swing constants, center, and then I have another label, devil right, icon swing constant center, and label 2, set horizontal text position, swing constants left. As you can see, you put the text position to be the left as for the label 2, and then label 2 set vertical text position as the bottom. So you put it onto the left bottom for label 2. So you can set the horizontal position, text position of the label to be left, and then also the vertical text position to be the bottom. Next thing, we have label 3, devil above, and then you set this horizontal text position to be center, and then the vertical text position to be bottom. You can do that too. Now what we do next is that I will show you shortly when we execute it. JPanel, so we will have the new panel created. Panel set background, so we set the background to be cyan, and then panel set preferred size. So we have this panel as a size of X 200 and Y 250, and then I add label 1. Obviously all these labels one by one. Label 1, label 2, and label 3. And now since I get my panel with 3 labels, I will add this panel on my frame as I did before, and then get the overall size of the frame and show it on the screen as the last statement. So let's try to... I hope I have the figure here. Probably no. Since we don't have the image there, it's not showing anything. Let me try to find that image if I can. No. But normally what would happen is that you will have the devil placed on the left of the text, and then devil on the right of this text, and then devil above this text normally. But since I don't have the devil.gif figure in the files, it is not showing the devil as part of the frame. Okay. Any question?
Why doesn't it give an error showing that?
It couldn't locate the file. It just ignores that that file and then executes it without the file. Okay. Any question? Normally, again, it's easy to understand how this is operating on the code. If you look into here, you see that this is the default thing for JLabel, devil left. So normally, the figure comes first, and then comes the text. However, if you change the orientation as you do with the label 2, devil is going to be on the right hand side because you put the text position onto the left, right? You have the text on the left, so that devil is on the right. The image is on the right. Or in the case of label 3, you have the text position, the horizontal text position on the center. However, you have the vertical text position on the bottom, so that the devil is above the text itself, or the label. Okay? You can play around with this example at home when if you would like to see how it actually operates on different things. So this is all about the introduction slides that I had before. We will go into Chapter 4 slides now. So Chapter 4 focuses on class definition, instance data, and then encapsulation and how Java modifiers actually work. Method declaration and parameter passing, how to pass parameters onto your methods. The constructors that we use, as you all know, there's default constructor. However, you can create as many constructors as you like, as your needs. And then the graphical objects, we will again see different graphical objects, events and listeners, and buttons and text fields. So on top of what we have seen so far with graphics part of the course, we will add additional things such as events and listeners, which, for example, whenever you click a mouse left button, what is going to happen? So for example, you will go open a new frame, something you may want to do, or open a file, or copy something. So you will be able to perform events based on the based on using the listeners, and we will add buttons and text fields in our graphical components to implement better applications as we go. So this part of the course is kind of a review of what you have, somewhat or partially review of what we have covered in CS 101. So if it has been long time since you take CS 101, try to follow it. Try to follow it, and if you have any questions or any problems, try to again repeat them at home if you feel like you're lacking some of the information that we are trying to teach here. So if you consider the objects that we use in object-oriented methodology or classes in general, we said that there are two things. One is, in every object, there are two things. One is the state of the object, and then the other one is the behavior. State is what is the status of the object, and behavior is what you can do with that object. Okay, so those are the two things. For example, for a six-sided die, dice, consider a dice, what you do is you can have its state as what it shows on the face, right? Face is whatever is defined on the face is showing. And then the behavior that you can have with the dice is that you can have, rolled, you can roll the die and generate a new face value. So that's the behavior. State is the current number that is shown on the face. And then the behavior is that what happens if you roll? What is the outcome of rolling the dice? So you can represent the die in software by designing a class called die that you can model this state and its behavior along with. Okay, so that's what we are going to do. Just to start with the classes again. We can instantiate as many dies as we like, so we can have multiple dies that we are playing around and using them. So if you remember, a class can contain data declarations and methods along with those data declarations. So when you look into here, in a class declaration, you have instance variables such as its size, weight, and then a character value category. And along with these, what you could do is you can use methods that you implement. So here we have the data declarations, and then we have method declarations which perform a certain task using this object or this class hierarchy in general. So the values of data define the state of the object that we are playing around. So the data values, the instance declarations that we use, actually indicate the state of our class. Whereas the methods actually implement the behavior. So whatever behavior that we would like to achieve is implemented by using the methods, right? Whatever is defined in my class. So if you go and see, as you can see in the die class, we have an integer that we can use to define the current state or what is the face value. And then for the behavior, we can have a roll method which is going to just generate a random number for rolling the dice, right? So those are the two things that we can do. Let me show you the example die class so that you have a better idea what I'm talking about. So public class die, so I define my class to have the name die, and then I have an private variable which is going to be an integer max identified to be 6, as you can imagine. This is the number that you can have with the die, and then this is defined to be as final, since you know that's a constant that you would like to have within this class. And I have another face value which is private int. Again, this is a private value to just hide it from outside world. It will only be available to my class, and this is going to be the current face value that I'm keeping. So this is the state that I mentioned, and then the behavior we will see is going to be the roll. So I have a method public int roll which is going to be generating a number as a result of rolling mechanism. So if you look into here, you see that this method is a public method, so it's accessible from outside and returns an integer value, and the name is roll. And when you call this method, what is going to happen is that it is going to change this state value, which is face value, to a new number which is generated by using the mathRandom class. You should have learned this in CS 101. So what mathRandom generates is that it generates a number between 0 and 1, right? So it is going to generate you a number between 0 and 1, and then you multiply it with the max value. What was the max value? It is equal to it's defined to be equal to 6. So you multiply this number with max and then add 1 to it. Why do I add 1 to that? In order to get a 6 value, because it is going to give you 0 all the way to 0.99 something. So whenever you multiply this with 6, if you multiply it with 6, what you generate as a result will be between 0 and something 5, right? Since it has been casted to integer, it is going to be, let's say it's 5.999 something. When it's casted to integer, it's going to just ignore the numbers after the dot, the decimal point, and then it will just get 5. So you will add 1 to that value and get a number between 1 and 6. So that's what exactly we would like to see, and that's what it is going to generate. And this method is going to return whatever is generated by this random method at the end. Okay? So this is the behavior of our die and what is going to be generated when you roll the die. As you can see, there's a constructor defined which doesn't have any argument. However, it sets the face value to be equal to 1. Okay, any question? And if you look into the mutator, it says public void set face value int value. So you call this set face value method in order to update the value, whatever is stored inside, by the value that is passed as an argument, and you update your face value to be this new value. And then you can access through an accessor to the same value by public int get face value. So this is accessor or a getter method, which gets you the value, get face value, returns an integer. So you return the object's integer value, which is the face value returned here. And then obviously, as we have in any class, we have the toString method, so which is going to generate a string as a result. And then whenever you call it, whenever you need a string to use, you're going to use this, and then the result is generated by integer to string face value. So this is what kind of a method is this? This is a static method which uses the class's name at the beginning, if you remember. If it's a static method, it is going to not use the object's name, but rather the class's name. So this must be a static because it is part of the integer class. And then toString method, as you can see, it takes an integer value, and as a result of that generates a string. So it converts the integer value to the string so that you can return it as a result. Okay. You could have just removed this part and return integer to string, blah, blah, but they have written it this way. Okay. Any question? So we design our die such that, with the other data and methods to make it a, reusable method. We have a runner class and then also the main class. I have shown you the main class. However, you can have a runner class which is here called RollingDice.java. I will show you that shortly. RollingDice. If you look into this method, as you can see, the name is public class RollingDice, and then you have the main method. So I defined two dies, die 1 and die 2, and then I have int sum. These are all declared, so I now have the two objects that are part of die, and then I have created those two objects. I allocated the necessary memory space for die 1 and die 2 by calling this method. So what it does is that here I define them, but I didn't allocate the necessary memory location. By doing the new, I will be able to allocate the necessary space for those two dies, and then I call the roll method so that it generates two results for my dies, and it is going to system out print line die 1, so it's going to print the results of die 1 and die 2, one after the other one. And I will roll die 1 again, and then set the die 2's set face value to be 4. So I force this to be 4, and then roll the first one. And I print that again, and as you can see, the sum is generated by adding the two values, get face value of die 1 and get face value of die 2, and then print that on the screen. And then another call which is going to roll these and add the results up, and we'll print the die 1, die 2, and sum again. So it's just basically calling multiple times the roll method and then setting and forcing the value and so on. So if I execute this and try to build it, so as you can see, it first generated the die 1 and die 2 as 2 and 6, and it is going to roll die 1 again to get a 6. However, it forces die 2 to have 4. Then it sums those up, 6 plus 4, and prints that on the screen. And then it rolls again, die 1, and then die 2 remains to be the same. And it adds those two up, sum to be equal to 9. And that's what it prints at the end. Okay. So it's just basically calling the roll method and set face value method and so on. Any question?
Maximum face value as we declared it 6, but in how we are going to prevent that.
You mean the set face value method?
Yes.
Yeah, that is going to, face value is not forced to have, as you can see, your friend is right. Whenever you pass any value here, instead of 4, what if I passed 6, let's say? So here we had set face value. If I had, let's say, 9, what is going to happen? What do you think is going to happen? Did it work? It worked without any problems, right? So what do you think we need to do here? As you can see, it assigned my dice value to be 9 and then used it in adding the result and generating the sum. So there is a problem here, as your friend pointed out. How should I correct this problem? So this has to be done within the die class. So whenever I'm calling the set face value, I need to prevent this somehow, right? So if I just use an if, you could use multiple things. For example, you could say, you could prevent that by putting an if statement. If, the value is greater than 6, assign it to be 6. If it is less than 1, assign it to be 1. So you limit the numbers that can be assigned. Or as your friend suggested, you can take a modulus of the value that is passed and use it. For example, if the user entered 9, you can just use value modulus 6 and then assign it. However, that is going to create another problem. What if you get a 0? How are you going? Yeah, you can just manipulate and assign the correct values or put it in some order. So your friend is right in this fashion. The class is not exactly correct. You have to prevent that kind of things to happen, right? You don't want to have values that are greater than 6. But the defining max itself at the top does not prevent that anyway. So this doesn't mean that your values, the face value, is going to be fixed with max. So it's just a declared constant value that we declare. That's all. You have to enforce it by using certain statements in your method calls. Is it clear? Okay, now, so this was a basic die class that we had. So if you look into the values, we had a constant max that is representing the maximum value and the face value. That is the instance data. So for each object, I will have one instance data that I'm keeping for face value, and I will use that. The roll method will use the random method to generate the overall result. As we have seen, the toString method will return the character string that is associated with the number that we use. So that's why we converted this integer to the string using the integer toString static method. Just these are brief reviews of what we have seen in CS 101. So pay attention to these. As mentioned before, we use constructors to create the object whenever it is first tried to be created. So there's always a default constructor which just doesn't initialize to anything, which doesn't have anything. So you don't have to have a constructor. However, it's usually a good practice to have a constructor to set initial values correctly for your specific class implementation. The constructor has the same name as the class name. So if it is a die, it is going to be die. Nothing that it returns. It's not a method call, so be aware of that. Let me show you that. So as you can see, public die, there is no method return, such as void, int, or anything like that. It just has the public keyword and then the name of the class. That's it. That's the constructor. If you have some argument that you would like to pass into this constructor, you will have these listed here. However, in this case, we don't have. It's just setting the face value to be equal to 1 initially as the constructor. The scope of data the data that is we are using here, need to be fixed in some borders. So you would like to do that whenever you declare it. And when you declare the data, it is used in, if it is used as a local data, that's called the local data. So if in a method you have a certain variable declared, that is called a local data, as we have seen before. So let me show you that. For example, here, as you can see, this toString method has a local data which is just used within this method, string result. So this is declared here. The area, the memory space is reserved for this string within this method, and then whenever this method is finished, the area reserved for this variable is released so that it can be used for other purposes. Right? So this is a local data that we declared only within this method. An instance data, again, for each object, if you have a certain data that is associated with each object, that is called the instance data, which in this case is the case for face value. So if you go back to the die class and how we created die1 and die2. So we created two objects, die1 and die2. Each one of them have its own instance data, which is the face value. So die1 has its own face value, whereas die2 has its own face value. This is called the instance data, as we have seen on the top. So we have public class die, and then I declare my instance data to be only face value, as declared here. For each object, I will have one face value. Okay? Whenever you define these, you actually do not allocate any memory space. However, when you call it with new method, whenever you created the with new, what you do is you actually allocate the space for it. So in this case, until this point, new die, until I called this, I did not allocate any space for my instance data for die1 and die2. I just declared what type of object they will be. However, the area for these objects have not been reserved yet until I call the new. So it's just graphically showing how it is done. Actually, you have the die1 object and die2 object, and they both have their instance variables, face value, with an integer stored as 5, and then another face value for die2, which does have a value of 2. So you have two separate instance data for two different objects, and they are stored in different memory locations. Whenever you update one, the other one remains to be the same. It is not updated. Each object maintains its own face value, as we have seen. So the classes actually, as we said earlier, the objects and classes have relationship between them. So we represent this using the UML, which stands for the Unified Modeling Language. And when you start playing around with your application and trying to come up with your design, we will ask you to come up with the diagram, UML diagram of your overall program. So that's something that you will have to do at the end. And this shows the relationships among the classes and objects. So which one is inheriting the properties of which one, which class uses what classes, objects, and so on and so forth. So you will list those. I will briefly show you an example of that. So it is composed of one or more classes with class name. These are the must parts, the class name, and then you have the attributes, the data that it is going to use and store, and the methods, that the operations it's going to perform on this class. So the lines between the classes represent the associations or relationships between the classes. And if you look into the specific example, dotted arrow shows that one class uses the other or calls its method. So when you look into this RollingDice and die example, as you can see, I have RollingDice, which has only a main method. There are no local data that is declared within this class, and it returns a void. So it takes arguments which are string array, and returns a void result. However, this is related to die. It uses die properties, which has a local, which has an instance variable face value type of int, and then I have methods roll that returns int, set face value that takes an argument int value, and then returns a void, meaning that nothing is returned, and then get face value, no arguments, however, returns an int, toString returns a string. So once you design your program with lots of multiple parts, you will have them these relationships. Obviously, they will not be standalone classes, right? Because you will have a main method, for example, main screen that you're calling everything else. Then things are going to be related to this, and this class will be using other things that are needed in your application. So you have to come up with such a diagram at the end, depending on the complexity of your program. You will see that things may get messy as you as you put the relationships in place. Any question? So encapsulation, as I mentioned in the previous lectures, encapsulation limits the relationship between the object and the outside world. That's what encapsulation is doing. So we can, for an object, we have two types of information. The internal one, so it is the details of the variables that are stored within the object and how they interact with one another. And then the external, the services that are provided to the outside world. So what can you see out of this object is the external view of the object. So this provides flexibility in implementing the inside without affecting the outside world. So basically what we have is a black box with just whenever we say something, it responds to us with a certain result. So the internal implementation is not concerned to us. It is already implemented. We don't care. We just know that if I ask for this, I will get this. So it's a kind of a black box. The outside world is not aware of it. And this is called encapsulation, and we use encapsulated entities and services for classes and objects. So one object called the client may use another object for the services that it provides, and the client will request these services by calling the methods, the public methods that are available. And any changes of the state within the object will be only available if a method provides this as a result of the call. And this is important. We should make it difficult, if not impossible, for a client to access an object's variables directly. So you won't like to have the outside world access your internal data or instance data easily, and you try to avoid that as much as possible. So as I said earlier, it's a black box. The client asks for something and gets a result, gets a response out of that. And this is, the instance data is managed by the class itself, the methods and data. Data is preserved or protected by the outside world by only giving access through the methods. So how do we achieve this? How do we achieve encapsulation? We use the visibility identifiers, mainly the public, protected, and private. So we will see what protected is actually going to do. However, we will start with private and public visibility modifiers. And just to note here that if you have a final modifier for constant, you don't really need to define it as a private because it cannot be changed anyway, right? Since it's a final, you don't need to declare it to be private. It can be public as well because nobody will be able to modify anyway. And we will see the protected identifier. It is used mostly in inheritance, and we will see how it behaves according to what conditions. So I think that is all for today. So we'll see you on Thursday.